What's up, guys? It's another day in the shop and we got another project for you. Let's get after it. Alright guys, so for today's project, we are going to be building a fuel cell. And this is a custom fuel cell that's going to fit right up in this flatbed. So the customer wants it to fit, I'm assuming kind of flush here. He gave me some rough dimensions on what he thought he wanted. We're going to kind of build it to that. He wants it to sit underneath this lip, so he still has the ability to look out the back window, obviously. It's going to be square on the back, it'll be tapered on the front, and it's going to be about yay high. The first issue that we may run into that I see, there's these brackets here for tying stuff down, and to get that fuel cell in here, we're going to have to snake it in one way and then swing it in. So we can't be too wide. If it's too wide, I don't think there's any way we're going to get it behind those, because the base is wider, so we can't drop it in behind it or it will hit. So that part could be tricky. And then we're also going to figure out how to mount it. But I think I got some ideas on how I want to mount it. Alright, so first things first, we're going to drag the plasma out. Finally getting some decent weather here in Utah. It's been a long winter. We're grateful for the moisture, but we're ready for some sun. And we're going to use our new outlet and see if we can't do some of this out in the sun, blow all the plasma slag outside. Let's go ahead and get our equipment set up and we'll go from there. Okay guys, so I got a rough drawing here. So it's kind of a trapezoid shape if you're looking at it from the front view. So our top's 73.5, bottom 75.5, and then you can see it's square in the back. It is sloped just like the back of the flatbed is. There are going to be some tricky cuts on this one because you've got a lot of angles going on. So it's tapered on the sides, it's slanted on one side on the back, but it's square on one side. So I'm going to get the front and the back cut, and I'll just start tacking pieces together. I'm going to wait to do the sides until the very end because I want to double check everything before I cut them out, because I don't want to screw something up. I just think that's the best way for me to do it, to keep from cutting material and having to recut material. We're going to go over, start laying it out, and start cutting.
Just like the street lights lit this town, like a fire in a blaze, gotta burn it down. Can't be afraid to leave this out. We got this far, don't know how. I see danger in your eyes. They know we'll burn down the night. Coming just like the sunrise. You know that we gonna let it rain. Tonight we gonna let it rain. Tonight we gonna let it rain. Just like the sunrise, we gonna let it rain.
Alright, so I just want to point something out real quick. I was cutting my side pieces out here. These smaller pieces that I can fit in the iron worker, I'm just going to shear them. Well, I laid these out, and hopefully you can see my lines here. I basically just drew a box. You got a side here and a side here because you've drawn this angle. This angle is the same, so then all you have to do is pull your top, your bottom. So you can see it's two pieces. They're side by side, but they're flipped like this. So you got a bottom and a bottom and a top and a top, and then you got your angle. Here's the problem. If you're building something out of diamond plate, you have to remember that it's a one-sided object. You want the diamond on the outside. So if I was to cut this like I had it laid out originally, I would basically end up with two left sides, or two right sides, whatever it is. Luckily, I caught it before I went over and cut them out. So what I've got to do, I'll have a bottom and a bottom and a top and a top, and then my angle will be here, and this piece will be scrap. So I just wanted to throw that out there. You got to remember when you're building stuff with diamond plate, it's one-sided. If it was just regular plate, it wouldn't matter. But because you have to have the textured side out, you need to pay attention to how you lay it out. Just another pointer. Alright guys, so we are to the point where we're going to start cleaning up all the edges on this. So I'm just going to take a flap wheel, hit all these edges where I've got plasma slag, and I'll just hit everything. Even if it does have a factory edge, I still will hit it with a flat disc just to make sure I get it as clean as possible. So we'll go ahead and hurry and clean all these up, and then we'll go from there. Alright guys, we're ready to start fitting this. So we've got our bottom piece and our back piece. We're going to stand this up, throw some tacks on the inside. We're going to do solid open corner welds on the outside. That's going to seal the fuel cell. But we're going to put some tacks on the inside just because it's easier to fit that way. We'll get the bottom and back piece on, and then we'll do the sides. Once we get it to that point, we got to start figuring out baffles. Whenever you have a fuel tank or a fuel cell, especially one that's going on a vehicle, you want to make sure that you put baffles in it so that it prevents the fuel from sloshing. It also makes the fuel cell or the tank more rigid. We'll go ahead and get this fit up, and then we'll go from there. I'm going to give you guys an update on where we're at because there's been a lot go on, but I haven't recorded hardly any of it because most of it's just boring for you guys to watch. it's all tacked up. We've checked the fit twice, and twice it did not fit. So we brought it back, had to trim it. We had to steepen the angles on the sides, and then we also had to trim the top, because when you steepen the angles on the sides, you shorten it. So we have been hard at it and gaining not a lot of ground. So this is the size that the tank's going to be. That's the good news. So what we're working on is some baffles. Now, if you're going to build your own fuel cell or fuel tank, you want to make sure you put baffles in it, especially if it's for a vehicle. If it's just a fuel tank that you are going to use on your property that's stationary, you really don't need baffles. But if you're going to use it on a vehicle, you want to use baffles. And when I say baffles, what you're doing is you're basically making some chambers in the tank, and they have a couple holes in them so the fuel can get from chamber to chamber, but it keeps the fuel from sloshing as you're driving around. So we're going to put 2 baffles in this tank. That should be sufficient for the size that it is. So this is one of the baffles, and what we're going to do, it's going to weld in like this. I'm just going to take a hole saw, and it'll have 2 half moons on the bottom here, so the fuel can get from side to side, and that's basically your baffle. We're going to go ahead and throw these in the mill. We'll cut the holes with the hole saw, and then we'll be ready to tack the baffles in. Once the baffles are tacked in, then we can start tacking the front side, which we still haven't cut yet because I wanted to get this fit. That's why I waited, because now that I know this is the size that it's going to be, all I got to do is pull measurements from corner to corner, inside corner to corner and inside corner to corner, and then lay it out and cut it, tack it on. So that's where we're at. We're going to go over to the mill and get these holes cut. Okay, so we've got this jimmy rigged here in the milling machine. We got some clamps on our table holding the plate down, and we're going to see if we can't just do some half moon pieces here in the bottom with our hole saw. I'm going to put the drill bit in the center, just barely on the plate, and then we'll see how this goes. Alright, I think that went pretty well. See if we got enough travel here. It is. Okay, so I think it's going to work. That'll let the fuel pass through, and it'll prevent it from sloshing. So now we got one more of those to do, then we can get them tacked up. Alright, so we got our lines transferred. This was just a practice run. I always like to have 1 or 2 practice runs just to warm up my arithmetic. That's why they have a squiggly line running through them, because my arithmetic was not warmed up yet. We got it figured out. We've divided it into 3 equal sections. And so now we know where to weld our baffles in. We don't need to put a ton of weld where the baffles go, but we do want to do some small stitches in there, because a very common issue that fuel cells have, a lot of times when people fabricate a fuel cell, they don't put big enough welds inside, and because they're always moving around, because the fuel in there is sloshing around, the aluminum can flex, and as it flexes over time, if you don't have good enough welds on the inside holding the baffles together, they'll crack, and then the baffle will fall over or just be kind of hanging out and just flapping around. So we want to make sure we put some decent sized stitches inside to hold the baffles in place so that the customer doesn't have any issues with it in the future. So now we're ready to go ahead and tack these in. So that's what we're going to do now. Okay, so we want to give an update here. We got these stitch welded in, both sides. There's a little soot in there. I'm going to clean this out before I seal it up. We did get it stitch welded in. The more I thought about it, I think we do need one more of those half circles at the top of this. So there is going to be a port in this chamber at the top. It'll have a 2-inch threaded coupling, and then he can screw a breather cap at the top. That's where he'll fill it, and that's also where it's going to have the ability to breathe. So I think we're good now. I think we're ready to slap this top piece on and get it tacked on. So we'll go to that point now. Okay, so obviously we decided to put some more holes in the top. Just the more I thought about it, the fluid can get distributed throughout the 3 cells, but to help it breathe, I just like the thought of having another way at the top for the fluid to get from chamber to chamber. That way, as it's sucking down, if it's really full, I don't want it to have issues breathing, because if the tank doesn't breathe and it's getting sucked down, it'll cause the tank to implode. So just to be safe, we're putting one more at the top. I'm going to go ahead and deburr these new cutouts, and then we'll start fitting the front side.
It's time for today's super cool tool.
Okay, so for today's super cool tool, we're going to be talking about porta-powers. So right here in front of me, I've got 2 different porta-powers, 2 different brands. I did pick them both up secondhand. I believe I paid $150 for this big one, and I paid $200 for this whole setup here. I currently don't have a hose for this larger pump, but I am in the process of getting one, and I'm always looking for different size cylinders and things like that to try to improve my arsenal. The 2 brands that I would recommend are actually the 2 brands that are sitting in front of me. It's not that I'm biased, but I have ran a lot of equipment, hydraulic equipment, specifically in these 2 brands, and they are both awesome. They are expensive, but if you can find them secondhand, maybe even if they need a little work and you can fix them, it's definitely the way to go. All porta-powers pretty much operate the same way. They have a valve, you close the valve, and then you pump, and that builds pressure, which raises the cylinder. Once you've ran the pump as far as you need to, you open the valve, and that releases the pressure. The cylinder goes down. Like this unit here, the valve is up here on the front, and it's about a full turn. So if I close the valve and then I start pumping, you can see the cylinder goes up. When I'm done, I open the valve, cylinder goes down. Porta powers are used to bend things, to flex things, to lift things. That's where porta powers really shine. So it's an extremely handy tool. I'm sure you guys have seen me use them a couple times here on the channel. So I would recommend, if you're in this line of work, or if you just want to add one to your tool arsenal, I would look into getting one. Both of these units are rated at 10,000 psi, but that translates to the ability to lift a lot of weight. So keep your eyes peeled for used ones. If you guys have any other questions about porta powers or what I use or any other tool here in the shop, drop a comment in the comment section. And that's going to wrap up our super cool tool for today. Let's get back to the project. Alright guys, I got a full belly, so back at it out in the shop. So now really all that's left to do is to weld it out. I'm going to bounce around, try to distribute the heat. Let's throw some music on, get a little time-lapse action. We'll see if we can't get it welded out. Alright guys, we're back out here today. We're going to continue working on the fuel cell. So we got the fuel cell back in. I did mark with a Sharpie where I think the fill port needs to go. This spot right here is still accessible from the ground, so when he pulls up to fuel, he'll be able to fuel this up. I did receive in the mail the other bung, and this is 1/2 inch. So this is the one that's going to go on the bottom. The only question is, I've got to figure out where that's going to go. And I don't really know where that's going to go because I need to talk to the customer and see if he's got a certain spot he wants it. That's kind of where we're at. While I've got the fuel cell back in the truck, the other thing I want to work on is the mounting brackets. I've got 2 pieces of 1/4 inch diamond plate here. We'll go ahead and clean them up around the corners, punch them, break them, and then I'll probably get them up there, tack them in place, then I'll pull them back down, get them back on the bench, weld them out right here. Let's go to that point. The hole saw is not round, so it actually kind of wallered the hole out for me. So I just need to clean it up a little bit and it's going to be perfect. Alright, so here's where we're at. I took our deburring tool here, cleaned the inside of this out. It had some pretty wicked burrs on the inside there, so I got them. But I got my coupling here, 2-inch coupling, 2-inch threaded coupling. I've marked 1/2 inch up on all 4 quarters. So I'm just going to set this down in there 1/2 inch. That should give me enough room to weld it out. So I'm going to try to get this tacked in here now, and then we'll go from there. Alright, so we got the fuel cell back up in place. Our brackets fit good. I like how everything's laying out. I've measured it and it is centered, so I'm ready to drill these holes. So now I've just got a 3/8 bit and I'm just going to drill into this rack. We're spitting on the box now. Okay, so now we're ready to get some bolts in there. Obviously we're going to use stainless steel hardware. Now we got to figure out where to drill the hole for the coupling underneath for the transfer port. Alright, so getting these bolts in is going to be trickier than we thought because you have to, it sits behind this. You got to go in one end, swing it in, and then shift it over. You can't get up under here to hold the bolt. So this is going to be one of those nearly impossible tasks to get those bolts in. And I thought about tapping it, but it's aluminum. And I really don't like tapping aluminum because it's so soft. We'll try it, but we're only going to try it one time. So now that it's in place, the holes are lined up. I don't want to get the bolts on, drill the hole in the bottom, pull the bolts, swing it out, weld it on. So we're just going to do this all at once. I'm going to drill the hole in the bottom right now. So that's where we're at. That's what we're going to do right now. So I'm going to crawl under there, and I've got a pretty good idea on where I want to drill the hole. The thing is, the issue we're running into is I really would like this to be protruding out of the tank. The problem is there's a lip on top here, so you've got to be under that, and you got to slide the tank in and then swing it over and slide it over. So we've got to drill a big enough hole and maybe even slot it so that we can drop this into the slot and swing it over so that we can get the tank in place, because there's no way if this is protruding out. I'm just going to try and drill this hole, and then we'll slide the tank out of the way and do some calculations on how far we need to slot it so that we can get it in there. Okay, so there's our hole. I think that's about as good as we could ask for, honestly, for a guess. So let's get the tank back over to the table and we'll figure this out. Alright, so our aluminum coupling has a little teeny shoulder on it. Hopefully you guys can see that. The measurement right here is 1 inch. So we're going to drill a 1-inch hole. That way it's got a little shoulder that it'll sit down in nice and neat. And then we'll be able to weld that out. That's what you call getting lucky right there. So now I got to get that out without it falling in. Ah! Luckily, the 2-inch coupling's on the top. We'll be able to get it out that way, but that's how she goes. I'm gonna get some tacks on that. We'll get this up here and see what it looks like. Sweet. Perfect. Whew. The angle's got to be just right to get that out of there. Alright, not the greatest, but it is sound and it is sealed up. I'm gonna go look for a plug, something I can plug the top with. We're gonna do that now and then test it and see if it leaks. So what we're gonna do is we're gonna pressure test this. Now I did go to the hardware store and I picked up a 2-inch PVC plug. So I'm gonna screw this in here. You can see I've got some Teflon tape on there. So I'm going to screw this in. Probably just go hand tight. Shouldn't need more than that for what we're doing. So now I'm going to pump it up a little bit with air. Now you don't want to put too much obviously because you don't want to blow it up or split all your hard work or anything like that. So we're just going to put a little bit in there, enough that it's going to hold some pressure so that we can take our spray bottle with some dish soap and water in it, and then we'll go over all of our welds, fittings, and make sure that it's not leaking. For something like a fuel tank, you want to make dang sure it's not leaking when you send it back to the customer. Got another trick up my sleeve. Raided the wife's craft drawer. So this is floral wire. It's extremely thin and it's very pliable, but it's also very strong. So might be something good to keep in the shop. So I'm going to wrap it around this bolt and I'm going to see if I can't pull it through once this is in place. We're going to see if it'll work. I might have to get fancy with my knots here. So we got to feed it through the hole. Alright guys, we got the bolts in. Still going to spray it down with Windex and wipe it down so it's nice and shiny for when the customer gets here. I'll go ahead and give you guys a walk around of the whole thing, give you one last look. He'll still be able to use that space for tools and stuff. I did bend these out so that he can still use them if he wants to tie stuff down. I think that's going to be perfect so he can still reach it from the ground. Looks pretty sweet from the side, I think, because it looks like it's part of the truck. I don't think it looks too awkward. I think it looks like it was meant to be there. Show you guys the bottom side what it looks like. There's the drain port right there. He did tell me on the phone he's going to get some sort of a actuating valve that he can control from in the cab. So he'll have a switch in there. When his tank starts getting low, he'll hit the switch. It'll open the valve. It'll drain this tank into his primary tank, and he'll just keep on driving. So he'll definitely more than double his capacity. So that's going to wrap up our aluminum diamond plate fuel tank. Hope you guys enjoyed it. It's kind of a cool project, a little different. It definitely had its challenges. So if you're not already a subscriber, please like, subscribe, and share. Thanks again for watching. I will see you on the next one. Alright, so I just want to point... Son of a gun, that's annoying. So we got the we got the 4 sides. We got 4 sides tacked on here. Son of a bee. Hello. We had to steepen the angles on the... We had to steepen... We're going to go ahead and put these in the mill. Inside corner to corner. And inside corner to quarter. So, that's where we're at. We're going to go over to the mill and get... So that's where we're at. We're going to go over to the mill and get those holes. So that's where we're at. Oh. All right. Okay. Okay. All right. All right. Okay. That's why they have a squiggly line through them. That's why they have a squiggly. That's why they have a squiggly line. And when it gets full, there's a lot of pressure. I don't want it to have, so I'm gonna go ahead. You're hot? Yeah. What the freak?
Well, I think that's just because I was heated up because it was freaking hot.
Heated up from the dance, I'll bet you are.
It was hot.
That's what happens when you dance close to them women. So, what was it?
It was good.
How many slow dances?
7.
7, you counted. And how many did you dance with the girl? That's my boy. I like it. Turn the weather off.